In this episode,
the heat pump can operate down to between minus 20 and minus 25.
We are already getting to minus 10.
I want you to get in trouble.
Forbid the installation of fuel-only standalone boilers.
Actually, I think it was a great idea.
Every degree you're moving up, you're adding 2.5% to your electricity bill.
At those temperatures, we could get to 200% efficiency.
Now there is a problem with biomass, actually.
Main grant money as a feed-in tariff, essentially, for heat pumps. There you go, yes.
Most manufacturers have software that'll cut the heat pump out at minus 25.
Welcome to another episode of Homeowners Q&A. I'm your host Mars, and today we're diving into heat pump performance in extreme or very cold weather. We'll be discussing what homeowners can expect when temperatures drop, how heat pumps compare to traditional heating systems in extreme conditions, and the best practices to ensure optimal performance. Joining us today, we have Rob Stevens from HeatForce, Brendon Uys from British Gas Net Zero, Carlos Lopes from the Swedish Energy Agency, and Andrej Hasta, a homeowner from Slovakia. But before we get started, we'd like to say a huge thank you to Good Energy for sponsoring today's episode. Starting out as a renewable energy supplier 25 years ago, Good Energy has grown to offer heat pump, solar and battery installations, smart energy tariffs and electric vehicle charging solutions. Here are just a few reasons to choose green energy for your next green upgrade. Good Energy is the only B Corp home energy supplier in the UK, proving their commitments to people and the planet. Their quality is also guaranteed because Good Energy only installs premium hardware that's built to last, and that's backed by long-term warranties. And there are no third parties, just directly employed, highly qualified and accredited teams that treat your home with respect. To find out more, head over to goodenergy.co.uk. Brendon, when we talk about extreme cold, how well do heat pumps typically perform in sub-zero conditions? And at what point do they start to become ineffective?
Heat pumps work very well at low temperatures. I think you've got to understand how a heat pump works before you can understand what it can actually do. What we're doing with a heat pump is we're taking low-grade energy and lifting it up to high-grade energy, and that's a high temperature. The further you lift that temperature, the more it costs you in energy to lift that temperature. We use what's called a vapor compression cycle to move that energy. What that cycle does is it allows the system to absorb the low temperature, usually unusable energy, and pushes that up to a high temperature. The way that works is by compression and decompression. When you compress a gas, it raises temperature. Think about when you are pumping your bicycle tire. When you hold the end of the pump, it gets hot. That's not friction. That is the raise in temperature when you are compressing that air. That is exactly what the compressor does on your heat pump. As you push the pressure up, the temperature rises. There's a direct correlation between temperature and pressure. There's two sides to that. Now, when you think about pumping a flat bicycle tire, it's very easy to pump and move the air around into the tire. There's not much friction. Your pump is easy to push, but as you start raising the pressure in the tire, hence the temperature, the more energy you require to actually push that pump shaft down into the pump to actually push the pressure into the tire. You'll eventually get to a stage where you cannot push that pump shaft anymore. You've run out of energy. That is exactly what is happening with a heat pump. The higher the pressure, the more energy we require to achieve that pressure, and because there's the direct correlation between temperature and pressure, hence the higher the temperature we require, or the higher differential temperature between the source and the delivery, or the more energy and the higher your bill is going to be. All refrigerants that we use have an operating zone or an envelope, what they call an envelope. It cannot operate outside that envelope. That envelope is determined by all sorts of conditions. It's not just the refrigerant, it's the compressors, it's all sorts of other things involved. It gets very, very complicated. But basically, on a modern heat pump, the heat pump can operate down to between minus 20 and minus 25 within its envelope. So as you start getting down below about minus 5, minus 6, somewhere like that on most units, the maximum delivery temperature starts going down with the source temperature. Yes, heat pumps can operate down at minus 25, but the delivery temperature will not be the maximum. It'll be reduced. And some of them at minus 25, you're only going to get 35 or 40 degrees out of it. And that's the maximum. In a crunch, yes, heat pumps will work down to minus 25, but there is a limitation as to the flow temperature it can achieve. In the cold climates, the distribution system has to be exceptionally good to operate at very low temperatures to allow the heat pump to supply at the very low ambient temperatures. And then it works fine. Coming back to that pump, the more we push the heat pump, the higher the differential between your source and your delivery temperatures, the more it's going to cost. The rough rule of thumb is approximately 2.5% per degree rise away from your source temperature. Every degree you're moving up, you're adding 2.5% to your electricity bill. And that doesn't matter where in the scale you're running.
So you basically said that the temperatures for most air source heat pumps up to minus 25 degrees, that's when they start to become what we can term inefficient.
No, that's wrong. That is when the heat pump will stop working. Most manufacturers have software that'll cut the heat pump out at minus 25. Not all, most of them do, but you do have units that will work below that.
Do you need help understanding your heat pump? Then pick up a copy of From Zero to Heat Pump Hero, an essential guide offering practical advice and basic instructions for new heat pump owners to maximize system efficiency. Available in print and on Kindle, link in the description. Carlos, Sweden has one of the largest adoptions rates of heat pumps in the world. Brendon's just said, you kind of get to minus 25 and those heat pumps kind of cease to work. How is it that Sweden has managed to get such a massive adoption rate given the incredibly extreme cold weather that you can actually get in Sweden?
Thank you, Brendon, for that explanation. It was very good. So what you call extreme weather, it's actually not extreme. It's just called, I work a lot with the eco-design regulations, which sets a minimum performance standard, and the energy label. The energy label for heat pumps, well, for all heaters, and heat pumps, it's one of them. The performance is shown with 3 climate zones. There is an average climate zone, and that's a climate of Strasbourg, and most of Europe is there, and UK is there. Then there is also a colder climate zone. I just looked at the map. It's only some islands, which I guess it's part of Scotland or Shetland, something like that are cold. But a big part of Europe is actually cold. So extreme, I would say that's more the Arctic regions, the north of Sweden. The rest is just cold. So it's not really a big problem. And the cold is the climate of Helsinki in the energy labeling regulations. And it should be the coldest that you get. I guess it's about minus 19 or something like that. So, of course, for the reasons that Brendon explained, it's a problem for air source heat pumps. So it's possible today. You have more and more heat pumps that are working down to that temperature. When it gets very cold, then you have to add electricity, which is resistive electricity, or you have to oversize very much your heat pump. So I would say that in the Arctic regions, or when it's very cold, and even when it's just cold, it's better to use a ground source heat pumps. It's true that Sweden has very good conditions to have ground source. It has become very efficient. You can have somebody drilling more than 200 meters in one day. This kind of skills is something that are needed if we want to have a huge deployment in Europe of heat pumps in Europe. When you have a ground source heat pump, you are actually making the exchange with the brine. You don't reach those very cold temperature. Then you don't have the problem that Brendon was actually describing. You can have a quite high performance even when the air temperature is very low. What you will have is that when it's very cold outside, then the temperature of the water that you will go to the radiators will be higher as well. So it will still work with a less efficient than otherwise, but it will work. What is important is to have also the hydronic part. So the distribution of the heat into the house will have to have either low temperature emitters or floor heating. And we're also working now to have a label on low temperature emitters so that the buyer can know exactly the performance of the emitters.
Have you got questions about heat pumps and renewables? Then head over to the forums at Renewable Heating Hub for practical advice from thousands of fellow homeowners and heat pump users. The one thing that we typically hear in the UK and why there's such a big resistance, I think, with a lot of people is that they freak out that heat pumps don't work when the temperatures drop below zero. With Sweden being the case, it certainly does drop to below zero quite frequently, as it does with you, Andrej, in Slovakia. So could you just give us an update on your system, what it is that you've implemented, and more or less what kind of temperatures you have to deal with on a month-by-month basis during the colder winter months?
The coldest temperatures are usually January, February. You can get from -20 in the morning to 5 degrees when the sun is in the right position. There are basically two things that are connected to the operation of the heat pump. You are not going to run it throughout the night when the temperatures are lowest. Basically, what we are calculating with it is 8 to 12 hours of operation, let's say, maximum. Those 8 to 12 hours can be within that period when the temperature is better. Let's say that those 8 to 12 hours are sufficient. The temperature, you don't require to wake up at 6 to 21 degrees, but you are satisfied with 18. Then you start with the operation of the heat pump when the temperature reaches, well, we are already getting to -10. That's usually the least you get at around 8. It's very rare to be below that temperature. The heat pump that I have with 9 kilowatt heater, whenever you need to heat more and the temperature outside just isn't sufficient, then well, you will pay that extra electricity. You will never go below the temperature you desire. You don't have to run 70-degree temperature into radiators. You can go with 55, you can go with 50. If you have enough of them, if the flow is right, you can go with 40. During those coldest temperatures, we've never had problem to achieve the temperature we desire. That's the first point. And the second, even at those temperatures, we could get to 200% efficiency.
Planning to install an ASHP heat pump? Then get your copy of Bodge Buster. It's packed with must-ask questions, real homeowner insights, and a practical guide for a smoother installation. Available in print and on Kindle. Link in the description. Carlos, you mentioned a couple of spots across the UK, or certainly Scotland, that do get a lot colder. Aviemore drops down to -8.2 and Tulloch Bridge drops to -8.8. So Rob, when it comes to designing heat pumps for people in the UK, and you do have, for example, a lowest temperature of -8.8 that you've got to work with, what is the process there to design a heat pump system and then ultimately choose the right size model and size to be able to heat that property when we do hit those kind of temperatures closer to -10?
First of all, it's a brilliant conversation from the rest of you, and I think a lot of really important points kind of touched on so far. When we talk about heat pump design, there's obviously a lot of variables, and some of the factors that the gents here have already talked about, like emitter sizing, pipework sizing, insulation levels of a house. For any homeowner, I guess, in the UK or anywhere abroad, what we calculate to is a instantaneous peak heat load. MCS at the moment regulates in the UK that we take into account things like the property height and the location and how exposed it is, things like wind chill factor, that allow us to calculate at a given design temperature, most of the time -3 is what they will advise that it's designed to, and an internal temperature of 21 degrees throughout the house. Now, obviously, that does vary from property to property. You're probably not going to want every room in your house at 21 degrees all the time, but 21 is a safe temperature to design to. We will look at, in that instantaneous moment, how much energy does that property need for space heating? And then based on things like what we call a U value, which is essentially just how well insulated the house is, we will then work out what that peak heat loss is. As an example, I would say that most properties that we tend to look at will have a heat loss in the region of somewhere between about 9.5 and 13 kilowatts. When we look at those kind of things, we will consider, for example, the existing system that the property has, whether or not that pipework is appropriately sized, whether the emitters are appropriately sized as well, and if any of those needed to be changed. Because as the guys said, with heat pumps, you ideally want to run it at as low flow temperature as possible.
You're listening to the Renewable Heating Hub Homeowners Q&A, empowering consumers with the knowledge they need to make smarter heating choices. When I look at the UK and the housing stock that's available here, you've obviously got houses and you've got built up areas, like London, Manchester, Birmingham. So you've got a lot of high density housing. How has Sweden been able to get high-rise buildings and all of that kind of stuff running on renewable heating?
That's a good question. Virtually all high-rise buildings, so commercial buildings and also multi-residential buildings, they are heated with district heating. That was the way to get rid of the fuel boilers, which we did anyway also for detached houses and for all kinds of smaller houses. But it's true that there are very few neighborhoods with houses that have district heating. I happen to live in one of them, but it's about 10% of the detached houses. When the density of the consumption is too low, then you don't have enough energy to cover the fixed costs of having a district heating distribution. For urban areas or where you have the high-rise buildings, then it's district heating. And district heating is running on biomass, on incineration. When they started to build them in the 60s, 70s, it was a lot of oil and coal as well. Now there is a problem with biomass, actually, with increasingly with the bioeconomy, with an economy that has to use materials that are green and more biomass. So it starts to be very expensive. The cost of it has increased, and also now there is more and more legislation regarding the sustainability of using wood. So what I see the solution is that the heat pumps will have to also to be used in district heating networks. Then they have to work at lower temperatures, and that's what we call also the district heating 3.0 with lower temperatures. The heating distribution system has to be adapted for that, and I think that we can reach a very high efficiency in doing so.
Can I have a question?
Yeah, go for it.
Do you use cascade systems?
I can't tell you about that. I guess that Brendon can maybe knows more about the technicalities.
Just to go back a fraction, district heating, we've installed a couple of low temperature district heating systems and running with SCOPs in excess of 4. It does work exceptionally well. It's got to be designed, again, it's got to be designed correctly, and the people operating it need to understand how it operates.
And what's the heating source for that, Brendon?
Ground source heat pump, yeah. I actually own a Swedish drilling rig, and yes, it can do 200 meters a day, no problem at all. And in the part of the country where I am, which is in the Lake District, it is similar to Sweden, where it's basically Sweden's granite, we're slate, but very similar conditions for the ground source. We can't put horizontal ground source in this part of the country, don't have the soil depths, and that's the same with Sweden as well. Cascade systems, not a problem. We've done many of them. You can actually cascade directly into the system without any form of separation. It does work exceptionally well. NEBI are very good at that. Their schematics and their design strategies don't involve any form of separation when it comes to multiple units. It's got to be controlled properly. It's got to be designed properly and installed properly for it to work, just like any system.
So, Andrej, the question that I've got for you, and which just occurred to me, so your heat pump at the coldest times of year is not running in the evenings. How do you prevent the actual water in the pipework from icing over? Because surely that must be a consideration.
This is a multi-split unit.
Would you like me to explain?
Go for it, Brendon.
What Andrej's got, his system doesn't have water outside. It pushes the gas into a unit inside, so it's not affected by the external temperature at all. It can go to minus 20. It's not an issue. The unit will start and run without any problems at all. There is no water that goes outside to the unit.
The only way you see that the heat pump is impacted by the temperature outside is defreezing. For the heat pump, the outside unit is 8 kilowatt peak. It uses up to 3 kilowatts, 4 kilowatts to start to defreeze.
Another side to that is, in the UK, we have to size the heat pump to 100% of the GT point, which is -3 or -5 or -8 up at the top of Scotland. In Europe, it's slightly different. They have a little bit of leeway. What a lot of systems do, and Andrej's is the same, is they have immersion electric add-on. That is where you can actually size your heat pump correctly, but have sufficient add-on to take advantage of the very low tariffs and charge your system up in the shorter period of time. So the heat pump is actually correctly sized, or maybe slightly smaller than it should be, but at the peak, very short periods, even in Andrej's case, he admitted it was only a week a year. That extra load is carried by the immersion element.
It's actually up to you. We just couldn't buy a heat pump which wouldn't have this. You can turn it off in the settings so that it never starts. Basically, this is the supplementary unit, as you said. Basically, it's more for people who want to feel the heat immediately. So that's a comfort function.
It's a very good point that the guys raised there about having backup heaters, because that's a lot of the questions that homeowners come to us and they say, okay, so you've designed my heat pump down to -3. I always design down to -5 because it's just safer that way. You give yourself a bit of a engineering leeway. But you've designed my heat pump down to whatever MCS delegates we have to, so -2, -3, whatever. What happens when it goes below that? There's a couple of different answers to that. As the guys mentioned earlier, it does not that the heat pump stops working. It doesn't switch off. It's not like, it goes into an alarm or it can't cope anymore. Let's say you've not done your design work properly and you've sized the heat pump exactly to the peak heat load of the property. At that point, your heat pump system would not be able to maintain the desired internal temperature. So it might be that it begins to drop from, say you designed 22 degrees in the house, the heat pump can only maintain it to 21. And it's actually a much slower decline, if you will, than I guess homeowners would imagine. I think the fear factor is my heat pump is going to stop working. But when we do this design work, the heat pump will be able to cope beyond the design temperature that we've gone to. And equally, a lot of units will have a integrated backup heater. There is also the option, and I've seen it on a few jobs recently, where people have got an additional backup heater if they really feel that they need that technology. And there's a range of manufacturers that either do them as a complete standalone add-on, so it's literally called a backup heater, and it's a form of an immersion where you can run part of your heating circuit through that as a backup. And a lot of manufacturers also offer an internal hydraulic station, so they might offer say an 8 kilowatt backup heater. You get a lot on commercial properties, and within that station as well, you might also get bits like your zone valves or a pump or some other form of compact station. So if that was a real concern for a homeowner in the UK, for example, who was in a very, very cold climate, and they wanted to know that heat pump could work down to -15 if we had some extreme weather, that you can also ask your installer about the possibility of adding a separate backup heater if there isn't already one on the heat pump. So the heat pump is still designed to cover 100% of the heating and hot water needs of the property, as MCS dictates, especially if you're going to be getting the boiler upgrade scheme grant towards it, which we have in the UK at the moment. But you can also have that additional peace of mind by installing an add-on backup heater as well.
You're listening to the Renewable Heating Hub Homeowners Q&A, empowering consumers with the knowledge they need to make smarter heating choices. So the more that we do these episodes, the one thing that is becoming very apparent to me, and something that I'm beginning to second guess now. So the UK is basically going through this phase of removing boilers and replacing them with heat pumps. The more I listen to this, as we are potentially going down the route of getting far more extreme weather, why aren't more of these systems being designed as hybrids? So we keep the boiler, we set up the heat pump to work to -2, -3. When those temperatures kick in and it becomes super inefficient, it kicks over to the boiler, because the boiler doesn't really care whether it's -40 or -5 outside. It really doesn't care. Why aren't we implementing more of those kind of solutions, Brendon?
Do you want my personal answer? Or
I want your personal answer. I want you to get in trouble.
I think the problem is it's more to do with protecting the customers than actually protecting the industry. Putting a hybrid system on can be abused quite badly. You can get very unscrupulous installers coming along and putting 2-3 kilowatt heat pumps on big systems that require 10-15 kilowatts and saying it's going to work and saying it's going to do stuff that there's absolutely no ways it can do. A lot of the hybrid systems we've come across over the years, the heat pump basically never works because it hasn't been set up properly, it hasn't been installed properly, and it hasn't been commissioned properly. It's quite difficult to commission the systems correctly. There are a lot of claims by a lot of manufacturers that they can do all sorts of things. I'm yet to see it, and I'm sure Rob's come across the same sort of scenarios. It is a good idea. I've got nothing against the concept of it, but I worry about unscrupulous operators taking advantage of the system.
Carlos?
Well, as I mentioned, I work with policy issues, and during the crisis, the energy crisis after the invasion of Ukraine, there was a Repower EU, so it's a kind of a paper where all member states and the Commission agreed to take a lot of measures. One of them was to use the Eco-Design Directive, which is setting minimum requirements, to forbid the installation of fuel-only standalone boilers. The only ones that would be accepted would be either heat pumps or hybrids. And then we would have a requirement that the report on how much energy should come from the heat pump.
You're listening to the Renewable Heating Hub Homeowners Q&A, empowering consumers with the knowledge they need to make smarter heating choices. I guess my bigger point is that in the UK, because everybody has already got a fossil fuel boiler, I think like almost every property has got one until it's actually being removed now to replace it with air source heat pumps. We've kept our hybrid system in place. We actually trialed HVO. The way that we've set ours up is that when it drops to, I think, -3 outside, the boiler takes over. Defrost cycles when it's below 0 are handled by the boiler. The boiler only comes on for 2 or 3 minutes. It just blasts that heat through, and it basically, in my opinion, makes our system a little bit more efficient.
Wrapping into the whole thing about hybrids versus cascades, I think that's a really interesting conversation. When you're looking at a property that has a particularly high heat loss, so in the UK with our building type construction, a lot of them are stone. A lot of older properties, cottages and so forth are made of 400, 600 mil stone. If the property is being renovated, whether it's listed, etc., there's often a lot of restrictions on homeowners for what kind of insulation they can put in their walls and really the kind of insulative values you can get. So we do often get heat losses that are kind of in the region of 14, 16, sometimes up to 22 plus kilowatts, which always, I think with a lot of manufacturers, once you get above the 12 kilowatt mark, a lot of single fan, single phase units can't really put out that type of heat. So the two options that we will discuss with people, and actually I had this conversation with somebody yesterday, is you can either go for a cascade system. If you put two 10s together, you get roughly a 20 kilowatt output and so forth. But I personally think that hybrids still have a really, really important place in decarbonisation and the adoption of heat pumps. A lot of people are either very for them or very against them. The hybrids used to be a little bit more popular because back when the renewable heat incentive was running many years ago, the government actually allowed homeowners to claim grant money as a feed-in tariff, essentially, for heat pumps. There you go. Yeah, so that was how the original grant was administered, as you would get drip-fed payments for using a heat pump, and that would depend on the type of system you had and so forth. But hybrids, as Miles well knows, those were allowed. And the way that they would stop people from fitting a tiny little heat pump with a massive gas boiler and then switching the heat pump off was they would require people to have what's called a heat meter fitted. So that would actually monitor the amount of generation that the heat pump was inputting into the total heat need of the property, and therefore allow people to claim that grant money based off of a hybrid. And again, keeping personal opinion and politics out of it, well, actually, I think it was a great idea because it allowed people that were on that much higher end of the heat loss spectrum to not necessarily have to rip out all of their pipe work, which is not always the case, but most commonly, you might see in a 200-year-old house, they could still have the same pipe work. So hybrids are a really good option for homeowners that either have very high heat losses or that want their heat pump to be operating down to absolute extremes. Like I said, if you want it to work down to -10, then you design the heat pump. Generally, what we call the bivalency point, which is, like you said, where the heat pump will pass over the heating demand to the boiler, is about 3 degrees. So positive 3 degrees outside is roughly where you would shoot for. And below that, you've got your fossil fueled boiler, which then picks up. And interestingly, I think we talked about this on the last episode, Mars, was a hybrid system, if designed properly and installed properly and commissioned properly, should provide about 75% of the total annual heat needs of the property. So it's a really good solution for the homeowner that has got a high heat loss, that maybe wants to retain some of the existing emitters, or maybe has unsuitable pipe work for running a very large cascade with very high flow rate requirements.
I still think that in this case it's more about choosing the heat pump. There should be, for any kind of property, some way of, let's say, choosing the variant which allows you to reach that high temperature. You can avoid dealing with hybrid systems by choosing a different model of a heat pump.
The biggest takeaway of today's episode is that I have a far better understanding of the actual limitations of air source heat pumps. There's absolutely no reason to me as to why a homeowner in the UK would not consider putting an air source heat pump in. So Carlos, what would you say to a homeowner in the UK that's watching this episode that says, the UK gets too cold, air source heat pumps won't work? From a Swedish perspective, what would you say to them?
As Andrej was saying, there are heat pumps on the market that can actually fulfill the requirements that you would encounter in the UK. I'm quite sure about that. There are several technologies, but even within the air source heat pumps, you have some that are designed to be able to work at low temperatures, outside temperatures, but also to go up to match a high temperature distribution system. Of course, that will cost in terms of efficiency. And what is important is that the buyer is sure that that heat pump is delivering that. That's why it's important to then look at the label, for example, and if there are low temperatures, and choose one that is declared for the cold climate. Don't go only for the energy efficiency at average climate, but go for the colder climate, because then that means that that heat pump has been declared and tested for those conditions. And we're also working, it's not yet decided, but to have the information that the heat pump can deliver also at a high temperature distribution system, for the heat distribution system in the house, up to 65 degrees. And hot water has to be produced at 55 degrees or something like that. That depends on the national rules.
Have you got questions about heat pumps and renewables? Then head over to the forums at Renewable Heating Hub for practical advice from thousands of fellow homeowners and heat pump users. So this wraps up this episode of Homeowners Q&A on heat pump performance in extreme or very cold weather. Again, a very big thank you to Rob, Brendon, Carlos and Andrej for sharing their expertise and experiences today. And of course, a huge thank you to our sponsor, Good Energy. Their commitment to renewable energy solutions, including solar, battery storage and heat pump installations, helps homeowners reduce their carbon footprint while staying warm throughout the winter. Thank you again for tuning in, and until next time, stay warm, stay green and stay tuned. Goodbye.